ways of discounting the price of the pizza. One of the ways is to take the cost of the pizza, which we don't know how much it is, and subtract how much money. There's your $5 off coupon. The other way to do that is to take the price of the pizza and multiply it by 10% to find out the overall cost. What I'm doing there, instead of taking the price of the pizza and multiplying it by 0.1 and subtracting it from the original price of the pizza, which is fine, the shortcut way to find percentages off is to multiply by its what you have left to get to 100%. Okay. So here's what you have. You have two different possibilities. You have two different combinations of the coupons. You can use the percentage off first and then apply the dollar amount, or you can apply the dollar amount and then the percentage off. Yes, sir. Does it? Negating the fact that the pizza has a restriction that it's going to be greater than $5. Nobody likes it. You know what? My kids, I like good pizza. I really like good pizza. My kids, let's get Little Caesars. Whoa. What's that? Right, as of right now? Right now it's a toss-up between the meat lover at World Famous or the what's the other one? The sausage pepperoni at Hobnar's is really good. They've got really good pepperoni there. So. So there's the first way of doing it. Take the G equation and surround it by F. Okay. Take the G equation and surround it by F. So I took the 90% of the original, the cost of the pizza, which is taking 10% off. Remember, what I'm doing here is like we did yesterday. Take the G equation, 0.9, and I'm surrounding it with the F. Hey, Tuna! Depends on, it depends. In theory, yes, but it always depends upon little things. But when you start thinking about it in big picture wise, yeah. Now the other way is to start with the x minus 5 and then surround that with the percentage off. Which means you take the $5 off first and then take 10%.
That's probably wrong.
So what happens then is you have two of them. And to be able to figure out what's the better bang for your buck is that when you distribute things through, remember you have 0.95 minus, or 0.9x minus the $5. And then the other one you have 0.95, or 0.9x minus $4.50. Which one of those is going to save you more money? Yeah, by taking the percentage first. Take the percentage first, you'll, in general, you'll save an extra 50 cents. Woo-hoo. But hey, when you're a broke college kid, 50 cents is 50 cents. Back in my day, that was a long distance phone call for 3 minutes.
Really?
I'm not kidding at all. We had these things called pay phones. You could actually make a phone call for 50 cents.
How long is the distance?
The one when you go the distance, do you go for speed? Are you all alone in your time of need? Are you waiting? Let's look at the other one. No, it's a cake song. She's going the distance. He's going for speed. all alone. I was hoping for somebody to just, I thought somebody was going to do the chorus in the background. I said, she's all alone. So it was said, in the time. So the other one here is a little bit different. In this one, you are dealing with two percentages. You're not dealing with a percentage and a dollar amount. You're dealing directly with multipliers. Yeah, and why is that? Well, you're on the right idea here. What happens here is, let's say you've got a 15% off discount on everything. Everything's 15% off this weekend only. I hate this. It's like
Or when
Kohl's.
they say this is the biggest deal of the year.
It's, I seriously, think about Kohl's for the love of all things.
Everything's the biggest deal.
Everything. If you go to Kohl's and you pay full price for something, you're just not doing it right.
Well, I'm sure it's impossible to pay full price.
So, just like Luke was saying here, when you start thinking about the idea that if you're just taking percentages, when you stack percentages, it doesn't matter because you're multiplying every time. And when you start multiplying things, does the order in which you multiply things matter? No. So you could still do the same idea as try to see whether or not you get a better deal for doing 15% off first and then 10% off, or 10% off and then 15% off. But you're going to find out that no matter what, you're still going to get the same value because multiplication is cumulative. Let me show you. If we take a g of f of x, oh, I should probably label them. So 15% off would be what is a decimal? If I'm multiplying something by to get 15% off, what do I multiply by? 0.85. And then g of x was 20% off, so that's 0.8. So if I go through this long form, if I want to figure out what the g of f of x is, I start with the f of x equation, 0.85, and I surround that with the g equation. Which means the other way, you start with the g equation, and you surround it with the f equation. So what this means is that when you take 10%, or sorry, you take 15% and then 20%, you're not necessarily getting 35% off because you're compounding your percentages. You're actually getting, math it for me, would you? I don't know, math. So what is that? How much percentage off is that if you're getting 0.68? 32. So it's not necessarily a straight 35% off. It's more like 32 because you're multiplying your percentages together. Does that make sense? Yes, ma'am. It's the original cost. It's because if you take 25% off or 50% off of $30, or if you take 20% off of $30, the $30 is the cost of the object, whatever you're buying. Nope, because it's two different discounts. I see what you did there. You missed it. Fog. You had fog lifted. Look, I lifted the fog. The fog dropped. I lifted it again. Yes, sir. No, I would like you to add these next problems to it. It's 45, same page you were on, it's 45 to 58. There's 2 word problems, and then the rest is just the function stuff. Yeah. Add to it. Okay, what's the numbers? I'm sorry. No. And that's the idea, because since you're not, there's no other. No, not necessarily. You're thinking of your domain what guys. I know I've given you a bunch of time here. Please keep it down. You'll get through this real quick. When you're talking about domains, if I want to look at the domain of f of x plus g of x for 47, that's a combined like term problem. When you combine those like terms, you're going to get x squared minus x plus 7. Is there any restriction upon x throughout the domain? No. There's no restriction because no matter what value you substitute for x, it's when you square it, it's going to be positive and so on. Your domain, therefore, would be all real. When I go to divide it, I don't know if there's one on here. If I do 57 or 58, if I'm taking g of x divided by f of x, I have the restriction in the denominator where x can't be the 0. Okay? You also will see that from time to time when you have square roots, because you can't have a negative root. So think of it as restriction. Yes, ma'am? In a minute. Let me save this and go from there. I was messing with you earlier. You didn't see me messing. I'm sorry. You didn't catch me. Apologize. You're so mean. Nice. Oh, I'm gonna do this first. Sorry. Come on, guys. You got some problems here. You can knock this out and be done.